रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा.
Hello and welcome to all students. In this lecture, we learn about scalar valued functions, and we discuss about the point continuity of scalar valued function. Okay. In the previous lectures, we have discussed the 3 points. Now our fourth point is continuity of scalar valued function. Okay, so let us start continuity of scalar valued function. Let us we define what is the continuity of scalar valued function. So let us define the epsilon delta definition of scalar valued function. A scalar valued function f from set S to R, where S is subset of Rn and S is not equal to phi, means S is a non-empty subset of Rn and it is a function from set S to R. Okay, and to be a continuous, we say that f is continuous at point A belongs to S if we have this condition: if for any given epsilon greater than 0 there exists a small number delta greater than 0 such that whenever distance between point X and A in Rn is less than delta, this must implies distance between f of x minus f of a in R is less than epsilon. Okay, so that is also a very simple definition of continuity of a scalar valued function, as we have defined the definition of continuity of real valued function. uh, on the same line we are defining here the continuity of scalar valued function. Okay, so here the distance, here the norm used to represent a distance between 2 points in Rn, and here the mod used to represent a distance between 2 points in R. Okay, so whenever distance between x and a is very small, this must imply distance between f of x and a is also very small. Okay, so then and then we say that the function f is continuous at point A. Okay, so we note some point here. A scalar valued function f is said to be continuous at point A if and only if limit of function f of x is f of a when x approaches to a. Okay, that is the very simple, as we have seen in the real valued function. Okay, now let us take some examples. First example is show that function f of x comma y is continuous at point 0 0 when where f of x comma y is equal to xy into bracket x square minus y square all divided by x square plus y square, and it is defined for all those x comma y which are not equal to 0 comma 0. And if x comma y is equal to 0 comma 0, then the value of this function is 0. That is the function which we have, which here defined, and we show that that function is continuous at point 0 comma 0. Okay, so we write the answer of this question. We show that for given epsilon greater than 0 there exists a delta greater than 0. Okay, to show that this function is continuous at point 0 comma 0, we use epsilon delta definition of continuity of scalar valued function. Okay, so here we show that for given epsilon greater than 0, we will show that there exists a delta greater than 0. So whenever such that whenever distance between x comma y and 0 comma 0 is less than delta, this must imply distance between f of x comma y and f of 0 0 is less than epsilon. Okay, so here from definition of function what we have, f of 0 0 is 0. So otherwise the meaning of this otherwise functional value, function has value 0 at point x comma y 0 0. Okay, equal to 0 0. So at 0 0 function f has value 0. So this is given from the definition. Okay, and also we know that norm of x comma y minus 0 0 is equal to square root of x square plus y square, but this norm is given to be a strictly less than delta. So square root of x square plus y square is strictly less than delta. Okay, so these two things we keep in mind. Okay, we will use in the next slide. Consider now, before going to the next slide, we consider this part. Always we are considering. So we consider this part to show that this part is strictly less than epsilon. Okay, so consider this part now. So that part is mod of f of x comma y minus f of 0 0. Okay, and it is equal to as f of 0 0 is 0, so it is meaningless. So we just write mod of f of x comma y. So f of x comma y minus f of 0 0 is equal to f mod of f of x comma y. But given that f of x comma y, it is defined like this: x comma y into bracket x square minus y square divided by x square plus y square. Okay, and now separate the modulus in this division, so there will be no change in these two steps. So new step will be equal to the previous step. Okay, so separate the modulus for each term. For this term, mod x mod y mod of x square minus y square and divide by mod of x square plus y square. Okay, against here we write less equal because here the mod I am writing here x square minus mod of x square minus y square is always less than equal to mod of x square plus mod of y square. That's why. Okay, but mod of x square is x square, mod of y square is y square. That's why in the next step here it is x square plus y square, and here mod of x square plus y square is x square plus y square, because mod of positive quantity is always that quantity itself. Okay, so x square plus y square is positive now, that's why x square plus y square as it is. And here also mod of x square is same as x square, mod of y square is same as y square, because x square is a positive quantity, y square is a positive quantity, it is not negative quantity. Okay, okay, non-negative quantity. Now uh, what we have is, we in the next step we will cancel x square plus y square with this x square plus y square, and this step will be equal. So equal to mod of x into mod of y, it is equal to square root of x square. So mod of x is square root of x square, mod of y, so mod of x is square root of x square, and mod of y is square root of y square. But square root of x square is less than or equal to square root of x square plus y square, and the square root of y square is again less equal square root of x square plus y square. So whole step is less equal this step. Okay, this will become say square of, okay, now it is, but this square root is less than delta, this square root is less than delta, whole term becomes less than this new term, this is delta square equal to delta square. Okay, so finally what we have, mod of f of x comma y minus f of 0 0 is strictly less than delta square. Okay, So now in the next slide we write here, finally we get mod of f of x comma y minus f of 0 0 is strictly less than delta square. Okay, so choose delta equal to square root of epsilon. Okay, square root of epsilon. So if I choose delta equal to square root of epsilon, then this becomes delta square becomes epsilon, and this step will look like this now. Okay, mod of f of x comma y minus f of 0 0 is strictly less than epsilon. That is our aim, to show that. And this shows that function f of x comma y is continuous at point 0 comma 0. Okay, so limit of f of x comma y is f of 0 0 when xy tends to 0 0, and thus function f of x comma y is continuous at point 0 comma 0. Consider the next example, example number 2. Check the continuity of the following function: f of x comma y equal to x cube plus y cube divided by x minus y for x not equal to y. It is equal to 0 if x is equal to y. Okay, and we have to show that this function is continuous at 0 0. Okay, we check the continuity of function f of x comma y at point 0 comma 0. Okay, we find limit of function f of x comma y at point 0 0. Consider the limit of f of x comma y, xy tends to 0 0. So limit of f of x comma y, xy tends to 0 0 equal to limit xy tends to 0 0 x cube plus y cube divided by x minus y. Okay, and choose path x minus y equal to, if I choose path like this, x minus y equal to m into x cube plus y cube, so here this path passes through the point 0 0. Okay, you can check which passes through the point 0 0. Okay, and if I choose this path, then our limit becomes like this: limit xy tends to 0 0 x cube plus y cube divided by m into bracket x cube plus y cube, and this x cube plus y cube get cancelled. It remains only 1 upon m, and the limit of this constant is 1 upon m. So limit of that function f depends on m. Okay, so finally limit of f of x comma y, xy tends to 0 0 is 1 upon m. Thus this shows that the limit of function f of x comma y depends on m, and for different values of m we get different paths passing through 0 0, and for these different paths we get different values of limit. Thus value of limit along different paths through 0 0 is not same. Therefore the limit of function f of x comma y at point 0 0 does not exist. Therefore function f of x comma y is not continuous at point 0 0. Limit does not exist, that's why it is not continuous. Okay, so this is our problem, and we have written some homework for you. At home you try to solve these problems. Question is, check the continuity of the following functions. So here 3 examples are given to you to solve at home. Okay, so write these problems.
रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा माणूस आता घडतो आहे. वटवृक्षाच्या विशालतेचा मोहन भाला पडतो आहे. रयते मधुनी नव्या युगाचा.